What will the International Space Station look like in 2050? Will it still be orbiting Earth, or will it have evolved into something completely new? Before we begin, let's be clear. This video is a scientific prediction, not an official NASA statement. Everything you're about to hear is based on current technology, real research, and the direction space exploration is heading today. Think of it as a possible future, not a guaranteed one. The International Space Station, or ISS, has been orbiting Earth for over 2 decades. It's the most successful international collaboration in space history, with astronauts from around the world living and working together above our planet. But as time moves forward, the ISS is aging. Its structure, systems, and technology were built for the early 2000s, not the mid-21st century. By 2050, one thing is almost certain. The ISS as we know it today will be completely transformed or replaced. NASA, SpaceX, and private space companies are already planning what comes next. Modular space habitats, commercial research platforms, and even rotating stations with artificial gravity. In this series, we'll explore what the future of the ISS could look like, how it might evolve, expand, and inspire a new era of human life in orbit. Let's take a look into the future and imagine the next generation of humanity's home in space. By the 2030s, the International Space Station will have reached the end of its operational life. Built in the late 1990s and expanded through the 2000s, the ISS has served humanity for more than 3 decades, longer than anyone ever expected. But like any structure in space, time takes its toll. Metal fatigue, radiation damage, and the constant stress of orbiting Earth at 28,000 kilometers per hour mean that eventually the ISS will no longer be safe to operate. NASA and its international partners have already announced that the ISS will be retired around 2030, marking the end of one of humanity's greatest engineering achievements. But that's not the end of the story. It's the beginning of a new chapter. Even as the ISS prepares for deorbit, a new generation of stations is already on the horizon. Private companies like Axiom Space, Blue Origin, and SpaceX are developing commercial space habitats designed to replace the ISS. These new platforms will be smaller, more efficient, and open not only to astronauts, but also to scientists, filmmakers, and even tourists. Axiom Space is already building modules that will attach to the current ISS and later separate to form their own independent station, a kind of next-gen ISS. Meanwhile, Blue Origin's Orbital Reef project promises a business park in space, where governments and private companies can rent labs and living quarters in low Earth orbit. So, while the ISS may fade from the skies by the mid-2030s, its legacy will continue. Reimagined, rebuilt, and reborn. And by 2050, these next-generation stations could be the backbone of human presence in orbit. A network of habitats circling Earth, serving as test beds for deep space missions and permanent life beyond our planet. By 2050, life in orbit could look very different from what we know today. Forget the narrow hallways and cramped sleeping pods of the old ISS. The space stations of the mid-21st century are designed for comfort, sustainability, and long-term living. The most advanced among them might orbit Earth at altitudes between 400 and 1,200 kilometers, forming a growing constellation of interconnected habitats. These new stations could be powered by high-efficiency solar arrays, with artificial gravity modules slowly spinning to simulate 1/3 of Earth's gravity, reducing the muscle and bone loss astronauts once suffered in microgravity. Inside, everything will be smarter. Walls embedded with sensors will monitor air quality, radiation levels, and even the emotional well-being of the crew. AI-driven assistants will manage daily routines, regulate oxygen flow, and schedule maintenance before problems even appear. Think of it as smart home meets space colony. Living quarters might feature panoramic windows with electrochromic glass, dimming sunlight automatically as the station crosses into daylight every 90 minutes. 3D printed furniture, self-cleaning surfaces, and hydroponic gardens will make long-term life in space more natural and far less isolated. And for the first time, civilians might live there too. Researchers, filmmakers, and even digital content creators broadcasting live from orbit. Energy won't come only from solar panels anymore. By 2050, wireless energy transfer from satellites and compact nuclear systems could power multiple stations simultaneously, creating an orbital power grid. That same network might one day extend to the Moon and Mars. The ISS once symbolized the beginning of human cooperation in space. These next-generation habitats represent the evolution of that dream humanity's first step toward a true self-sustaining civilization beyond Earth. By 2050, the International Space Station, as we know it, will likely be a memory, a proud monument to humanity's first steps into long-term space living. But what replaces it could redefine what we think of as a space station. This is not a confirmed NASA plan, but a projection based on current trends in aerospace development and technology research. Imagine orbiting cities built through international and commercial cooperation, massive rotating habitats where hundreds of people live and work in artificial gravity. These next-generation outposts would be built not as single modules launched from Earth, but as assembled megastructures, constructed piece by piece in orbit, using robotic arms and 3D printed components. The design philosophy will shift from temporary lab to permanent home. Each orbital habitat might include living districts, laboratories, production areas, recreation zones, and even green spaces maintained through bioregenerative life support systems, ecosystems capable of recycling air, water, and nutrients naturally. And here's where it gets truly futuristic. Private companies will play a massive role. SpaceX, Axiom Space, Blue Origin, and international agencies could each manage their own modules within a shared orbital network. Picture a space economy where satellites, refueling depots, and even manufacturing facilities operate as part of a single interconnected ecosystem. By 2050, these habitats could be linked through a low-Earth orbital highway where small shuttles carry cargo, supplies, and visitors between stations daily. Tourism may no longer be science fiction. Orbital hotels could host short-term visitors, offering panoramic Earth views and zero-gravity experiences for those who can afford it. This evolution marks more than technological progress. It represents a psychological one. Humanity will no longer see space as out there, but as part of our neighborhood, an extension of human civilization itself. The International Space Station began as a lab. Its successors may end up being cities. As we move beyond Earth orbit, the next great milestone will orbit not Earth, but the Moon. NASA's Lunar Gateway, already under construction in the mid-2020s, is projected to become fully operational and permanently crewed by the 2040s, evolving into humanity's first deep space outpost by 2050. Let's be clear, this is not a confirmed NASA timeline, but an informed projection based on Artemis program goals and ongoing international collaboration. The Lunar Gateway is designed as a small modular space station that orbits the Moon in a highly elliptical path. Unlike the ISS, it won't be manned continuously at first, but by 2050 that could change. With the help of advanced propulsion systems and autonomous modules, Gateway might become a semi-permanent spaceport connecting the Earth, the Moon, and eventually Mars. Each mission to the Moon's surface would dock at Gateway first, refueling, resupplying, and preparing for descent. Over time, this outpost would expand, gaining research labs, communication hubs, solar power arrays, and radiation-shielded habitats for longer stays. And here's where it gets exciting. Gateway won't just serve NASA. It's a global collaboration with contributions from ESA, JAXA, CSA, and private space companies. Think of it as an international airport, but in lunar orbit. By 2050, Gateway could also anchor a growing lunar economy. Cargo spacecraft may deliver equipment for 3D printing lunar habitats, extract frozen water from polar craters, and send valuable resources back to Earth. It might even coordinate traffic between multiple lunar bases, including research outposts and commercial mining sites. And for the first time in history, humans could live weeks or months beyond Earth's protective magnetic field, a critical test for future Mars missions. Scientists will study radiation effects, closed-loop life support, and psychological adaptation to isolation, knowledge that will shape the next era of human exploration. By mid-century, the Lunar Gateway will represent more than a space station. It will be the heartbeat of a new lunar civilization, a waypoint between worlds, a bridge between today's explorers and tomorrow's settlers. By 2050, NASA and its international partners may have achieved what once sounded like science fiction: a permanent human presence on the moon. While no official plan confirms this timeline, current Artemis missions and lunar technology programs clearly point toward one outcome: human settlement beyond Earth. The first lunar bases are expected to rise near the moon's south pole, where sunlight lasts for long periods and deep craters hide water ice. That frozen water will be the most valuable resource of all. It can be split into oxygen for breathing and hydrogen for rocket fuel. In other words, water will power life itself. These early habitats, often described as lunar domes or transparent biomodules, could be built using 3D printing technology that turns lunar dust, called regolith, into solid structures. They won't look like fancy glass buildings from sci-fi movies, but rather durable, radiation-shielded habitats, half buried under lunar soil. Inside, everything will be designed for efficiency: closed-loop life support, hydroponic gardens growing lettuce and potatoes, solar panels capturing energy, and advanced AI systems managing oxygen, temperature, and water recycling. Every drop, every watt, every breath will be measured and reused. The first crew members won't just be astronauts. They'll be engineers, biologists, miners, and construction experts, building the foundations for a self-sustaining lunar settlement. NASA's long-term goal is to make lunar missions less dependent on Earth, using local resources, a concept called in situ resource utilization, ISRU. That's how humanity will learn to live off-world, and the psychological challenge might be just as big as the technical one. Living in reduced gravity, separated from Earth by 384,000 kilometers, will test human endurance in ways we've never faced. But it will also unite science, innovation, and imagination. Because once we learn to live on the moon, Mars won't feel so far away. By 2050, if projections hold true, you might look up at the moon and realize there are people up there, working, growing food, maybe even calling it home. The moon won't just reflect sunlight anymore, it'll reflect our future. If the moon becomes humanity's first home beyond Earth, Mars will be the next frontier. And the two worlds will be more connected than ever. By 2050, the lunar bases built through the Artemis legacy could serve as launch and refueling hubs for deep space missions, changing how we explore the solar system forever. Here's the logic. Launching rockets directly from Earth is expensive and energy-intensive because of our planet's gravity. But the moon's gravity is just 1/6 of Earth's, which means it takes far less fuel to leave its surface. That's why NASA and its partners plan to use lunar resources, like water ice, to produce liquid hydrogen and oxygen propellant right on the moon. Imagine it. Spacecraft refueling at a lunar depot before heading toward Mars. It's the ultimate gas station in space. This idea is already being tested conceptually with projects like Lunar Gateway, a small space station orbiting the moon. By 2050, Gateway could be expanded, hosting multiple docking ports, science labs, and crew habitats. It will serve as the staging point where Mars-bound astronauts prepare for months-long journeys into deep space. And the technology developed for surviving on the moon, closed-loop life support, autonomous robots, radiation shielding, will be reused and refined for Mars. In that sense, the moon is humanity's training ground for interplanetary living. NASA's long-term vision aligns with this path. Artemis establishes permanence on the moon. Gateway connects missions. Mars becomes reachable. It's a step-by-step evolution, not a leap of faith. By 2050, the first Mars mission may already be underway, launching from lunar orbit, fueled by the moon itself. And when those astronauts finally set foot on the red planet, their first words might echo the legacy of Artemis. We came from the moon, not to visit, but to continue. Because in the grand story of space exploration, the moon is no longer the destination. It's the bridge between worlds. By 2050, the boundaries that once defined our world may no longer stop at Earth's atmosphere. The moon, Mars, and orbiting habitats could all become extensions of human civilization, connected through technology, ambition, and a shared dream of survival among the stars. This vision isn't just science fiction anymore. With the Artemis missions, private companies, and international cooperation, we're already laying the foundation for a multiplanetary future. Every launch, every experiment, every footprint in lunar dust is a step towards something far greater. The next chapter of human evolution. In this era, humans might live and work in low-gravity environments, grow food under artificial sunlight, and communicate across millions of kilometers as easily as we send a text today. Children could be born on the moon, study under Earth's distant glow, and dream not of becoming astronauts, but explorers of entire worlds. But this isn't just about technology or science. It's about who we become when we dare to leave our cradle. Space challenges our limits, unites our species, and forces us to think beyond borders, languages, and nations. Out there, we are simply human. One civilization reaching for the stars together. And while many of these ideas remain predictions and projections, they are grounded in real progress and current plans by NASA, SpaceX, and global space agencies. We might not know exactly what 2050 will look like, but one thing is certain: humanity is no longer confined to one world. As we look toward the future, remember, every great journey began with a single step. Ours began with Apollo, continues with Artemis, and will one day take us beyond even the red sands of Mars. Because the true purpose of space exploration isn't to escape Earth, it's to understand it, and to ensure that the light of humanity never fades.